Hi everyone, and welcome to this second lesson on Unit 40, all to do with probability. We're going to continue within looking this time at theoretical probability. Specifically, we're going to look to start with just at the language of probability and then some sample space diagram work. It might be that you're quite familiar with this stuff, but I want to make sure that you've got a really good understanding of this before we move on to the more difficult theoretical probability later on when we start talking about independent events, conditional events, using things like the words like mutually exclusive, independent, exhaustive, etc. It's really important that we get the language right first so that we are comfortable when we move on later. So in terms of where this fits into our topic scheme of work, we're specifically looking at this bit here about mutually exclusive events, but I'm linking in a little bit of this as well in terms of our sample space diagrams when we start to combine things together using words like and or. Okay, a little bit of note taking for your book then. So the key word, the thing that we're looking at here is all about mutually exclusive events. Mutually exclusive is all about when things cannot happen at the same time. So exclusive events are events that cannot happen at the same time. Please make sure that you've got at least one of these sentences, either this one or this one written down in your book. We're going to be using this throughout this lesson. At the same time, they are mutually exclusive. Not being mutually exclusive, things like turning left and scratching your head, they can happen at the same time. So they are not mutually exclusive. Similarly, you can have kings and hearts from a deck of cards because you can have the king of hearts. It can happen together. We're going to have a quick go at true or false. So I'm going to show you some questions and you're going to decide if you think it is mutually exclusive, true, or if it's not mutually exclusive, false. So question one, winning a football match and losing the same football match, is it mutually exclusive or not? Yes, it is, because they cannot happen at the same time. Having a pizza for dinner and having ice cream for pudding is false. They can happen at the same time. You can have pizza for dinner and ice cream for pudding. Even if your mum says you can't, you can. Getting the bus and missing the bus is true. They are mutually exclusive. They cannot happen at the same time. Watching a comedy film and watching a romance film, false, because you can watch a film that is both funny and also romantic. Being awake and being asleep is true. They are mutually exclusive. You cannot both be awake and asleep. Rolling a 2 on a die and rolling a number that is less than 3 is false, because a 2 is also less than 3. They can happen at the same time. And final one, traffic light being on red and also being on green is mutually exclusive. They cannot happen at the same time. Okay, next key word then, we're going to look at exhaustive events. So exhaustive is when the probabilities of all the possible outcomes add up to 1. So one thing or something else or something else or something else, we get all of the different combinations, all the different possibilities, and they must be certain when we've got them all, so they will add up to one whole one. Remember that your probabilities are always defined as being between 0 and 1 on our number line. So an example, the probability of getting a 1 on a dice is 1 out of 6. The probability of rolling of 2, 1 out of 6, 3 out of 6, 4 out of 6, and so on. These are our theoretical probabilities. Now, it might be that over time, as you will have seen in yesterday's lesson, that when you start to roll your dice, you don't exactly get this. But in theory, if you were to do it an infinite number of times, these are the probabilities that you would get. If you add them all up, you get 1. And that's because there is nothing else that can happen. You can only get a 1, a 2, a 3, a 4, a 5, and a 6 on a regular dice. So therefore, all of these are exhaustive. You have exhausted all the possibilities. Box containing 3 bags of salt and vinegar crisps, 4 bags of cheese and onion crisps, and 2 bags of beef crisps. One of these bags of crisps is taken from the box at random. What's the probability that they are beef? Okay, so in this case, we know that there's 3 out of 9, 4 out of 9. So in total, we've got 7 out of 9. Therefore, the beef ones to make it up to 9 out of 9, or one whole one, has got to be 2 out of 9. And again, we're using some very formal notation here. We're using the 1 minus. So we know they all add up to 1. We're doing 1 minus the sum of these two. 2 out of 9. So try not to get too worried about the actual mathematics that's going on. A lot of this is really intuitive. So whatever you think is going to be the case, make sure that you kind of think about that carefully, do the maths to double check, but then I'm sure you will be getting the right answer. Example 3, in a survey during a walk to school week, all the pupils at Winsford Academy either cycle, walk, come by bus, or still come in a car. The probabilities they travel each way are below. What's the probability they come by bus? So the first thing we need to check, is there any other way that they could get to school? Cycling, walking, coming by bus, or coming in a car? It seems that that is the only thing that we've got. We've got 3 things. We know that they add up to one whole one. So to get the final one, probability of getting a bus is 1 minus the sum of the other 3, which is 0.06. Okay, at this point, it's worth you practicing some of these skills about mutually exclusive and exhaustive events. On class charts, I've allocated a document, I've attached a document that is called Mutually Exclusive and Exhaustive Events Worksheet. Have a go at that now. If you want to type it up on the Word document, if you have the facilities to do so, feel free to do that. You can always email me that back and I can check to make sure that you've done it right. Alternatively, if you just want to do it in your book, that's fine. The answers will be on the next slide so that you can mark it yourself. And here are the answers for question 1 and 2. At this point, you might want to just pause the video and make sure that you're happy with all of the answers. Anything that you're not sure about, scroll back and make sure that you have understood all the bits and pieces that I've mentioned so far. And the answers for questions 3, 4, 5 and 6 are listed here. Again, pause the video, mark, and then we'll resume shortly. Game was thinking about horse number 1, done running, you will notice that that's never going to be the case. You're never going to get 1. However, all of the other possibilities are there. Some appear more regular than others. So if we're starting to look at the probabilities, the probability of getting a 1, well, you can't get that, so that's 0. None out of 36. There are no 1s out of 36 here. The probability of getting a 2, there's only one way out of 36. A 3, 2 ways out of 36. A 4, we've got these 3 here, and so on, and so on. And you can see that these are symmetrically distributed down here, with the most likely one to be is the horse number 7. So again, when you've played this, it might be that you've noticed that horse number 7 wins more often than the others. If not, and if you're watching this before you play the game, then you'll be able to get a little bit of an advantage over your folks at home. Okay, so 1's not possible, 7's most likely, 2 and 12 are the least likely to win, but it doesn't mean that they won't. Just means that if you were to play the game a lot of times, 2 and 12 will win fewer than 7 and so on. Next activity, there is a second worksheet that's on class charts. This is all about sample space diagrams. Again, if you want to do it electronically, you can do. Ideally, you do it in your book, so you've got those notes being taken in that regular way. Answers are going to be on the next slide, so you can pause the video now and have a go. And here are the solutions to the 5 questions on that worksheet. So again, make sure you're using your green pen, tick them off as you go. Any errors, see if you can go back and work out why. If you're really struggling, obviously you can contact me, you can email me and ask ask your question about why it was that you went wrong. And finally, there is, of course, extra work always available either on Dr. Frost, Corbett Maths, or BBC Bite Size. I haven't actually set anything on Dr. Frost this time for this particular one. I'm going to save Dr. Frost for some of the more formal examination questions coming up later in the week. Hopefully you found this useful. Please get in touch if you need anything, and I will hopefully see you soon. If not, then stay safe and look after yourself and each other. Thank you. Bye.